Bismillahirrahmanirrahim. Assalamu alaikum viewers, and welcome back with another video dealing with your integration by parts. And over here in this video we are going to discuss the non-terminating integration by parts, and we are going to handle such kind of problems by means of this method, I method. I just call it by myself I method. So the question might comes in mind, what exactly non-terminating integration by parts is. So in that case, I must say that the integrand which is so involved in in a certain integrals, which is the product of two functions, and if those two functions are of such nature that either their derivative or their integral both are representing functions which are having no end. Okay, they are periodic in nature and they are not terminating at all. So the example of such kind of functions, I have just maintained a table for you over here. You can see over here. So I have just picked few examples. You can see that if I just talk about my exponential functions, sine and cosine, the two trigonometric functions I've just picked, and another one is the exponential one. You can see that the derivative of exponential is exponential itself. Okay, and so do the integral. And the derivative of sine function is cosine, and the integral of sine is negative cosine x. So they are not perishing at all. They are not having end. Okay, they are not vanishing while performing these two activities. So same thing is happening with the cosine function as well. So if you're having an integrand which is the product of such kind of functions which are non-terminating, either their derivative or their integral, they're not contributing any such role in finishing up such kind of functions. So in that case, if you perform an integration by parts for such integrands, they are not going to get end. Okay, such integration is going to will keep on going on, and it is having no end. So it is non-terminating in common words. So how you're going to evaluate such kind of integrand? Okay, you are performing integration by parts, but it is not bringing any kind of end. It is not giving you a final answer. So what is the way of handling such kind of cases? So the way is the I method here. So I'm going to do two examples related to non-terminating integration by parts involving the product of such kind of functions. So let's have a look at the very first example. Okay, here you go, the example over here. You can see that the integrand is the product of these two functions. One is the exponential and another one is the trigonometric, and both these functions, either you take their derivative or you take their integrals, they're not going to come to an end. Okay, so they are non-terminating functions. So the product of such two functions is a non-terminating integrand. So therefore, once you're performing a by parts, this by parts is going to be non-terminating, in easy words if we say. So over here we are going to apply our I method, and for that purpose I just name this entire integral as my I. Okay, this is the starting. And you know, you are quite familiar with the formula of your integration by parts. You know that. Now once both these functions are having same nature of derivative as that and that of the integral, so you are free to take any function of this integrand as your f and as your g. It is your choice. You can take exponential as your f, trigonometric as your g, or you can take trigonometric as your f, exponential as your g. It is your choice. Okay, so I decided to pick up my trigonometric function as my f of x, a function to be differentiated here while performing the by parts, and this exponential I've taken as my g of x, the function to be integrated while performing this process. Okay, now once you differentiate both sides of this equation with respect to your x, you're going to have your f dash x. Okay, so this is going to be your f dash x. Okay, now you see that at the place of your angle of your sine, you're not having simply x, you're having 2x. So you have to apply a chain rule here. So before performing chain rule, just do it directly, that the derivative of your sine is your cosine x. So the derivative of sine 2x is going to be cosine of your 2x, and then you're going to apply a chain rule at the angle. Okay, all right, this is a constant number and this is the coefficient of the x, and you're going to take it out while performing the derivative. And dx upon dx is going to be 11. This, it is 1. Okay, so 2 cos 2x is your f dash x here. Okay, so let us highlight this. There you go. Okay, now we are going to perform over here in this function, we are going to integrate at both sides with respect to our x in order to get capital G. So integrate both sides with respect to your x. Okay, and you know that the formula of your integral, let me write over here for you, that the formula of integral of your exponential function is exponential itself plus some constant. And you know that if you're not in mood to perform substitution, because you know that I method is already too much lengthy, and if you perform a substitution method here while performing this integration, simple integration, if you want to apply substitution, it is going to further elongate the entire process. So once you perform, so just better use a primary formula for your integration. So you know that the integral of your exponential of your x is the exponential of x itself, and in the denominator you just take out the derivative of whatever the power you're having on this Euler number. Okay, you know this is the Euler number, e. So that's how you do. Okay, so if I just try to bring this primary formula in much general appearance, if I say that whatever the power I'm having on this Euler number, I'm not mentioning it. Okay, so it is going to be e of this power itself plus some constant upon the derivative of this power with respect to our x. So this is going to be my most general formula of my exponential. Okay, so I'm going to apply this thing here. All right, instead of using a substitution method over here that just let your 3x equals to u and then you take the derivative at both sides and then you replace dx by du and so on. But don't just plunge yourself in that long method. Just apply this basic formula and you're going to get your answer. So the integration of your, while doing the integration of this integrand, you're going to get the answer here. So exponential of this power, the exponential of this power as it is, plus some constant, and in the denominator you are taking the derivative of this power. Okay, so this coefficient is going to be written outside, and that's how the thing comes, and this is now 1. So finally the answer you're having is upon 3. This is your g of x, because the integral of small g of x is represented by capital G of x plus some constant. Okay, so there you go. So now we are having our f dash x, we are now having g of x, and small f and small g are also in your service. So just substitute in this answer, in this formula, sorry. So let's see what we are having. Okay, so let me put something here. Sorry, hang on for a second. Okay, So you see, I have to apply my by-parts formula over here. So as per the formula, it is small f capital G. So my small f was sine 2x and capital G was exponential power 3x upon 3 into sine of 2x. Alright, minus integral, and over here the f dash x was my 2 cos 2x, if you remember, and G, capital G, was exponential power 3x upon 3. So let me write. Okay, so 2 upon 3 is going to be written outside the integral. And as I told you that in the beginning, I just represented this entire integral by my I. So I'm going to write I here in the remaining steps. Okay, this is my 3 minus 2 by 3 integral of my e power 3x cos of my 2x dx. Alright, so now we are having this integrand. Again, you're having the product, the integrand is expressed as the product of two functions. Both are non-terminating, either if you take the derivative or the integral. So once again, you're going to apply a by parts here. So you can, just like in the previous step, we have taken the trigonometric function as our f of x and exponential as your g of x. You can follow the same pattern. Also, you can take exponential as your f or cosine or trigonometric as your g of x. It's your choice. So I'm just following my own the pattern that I have just adopted since from the first step. So I'm going to take my trigonometric function as my f of x and exponential as my g of x, just like before. Okay, so my f of x is this time cosine of 2x, and my g of x this time is going to be exponential of your 3x. Okay, so once when you derivate both sides with respect to x, so your f dash x is going to be the derivative of your cosine function is your negative sine of that angle. And as you see that the angle is not simply x, it is 2x. So you're going to apply the chain rule here. It's going to be 2x. So the coefficient is going to be written outside the derivative. So if I simply write it along with the sine 2x, it is convenient. And dx upon dx is left, and it is 1. So your f dash x this time is your negative sine of 2x. Okay, so this is your f dash x. Close it in a box, and there you go. Now integrate both sides with respect to your x, just like before you have done. So this time I'm not going to put down much explanation, so I'm simply going to write down the answer for you. So this is it, and this is my g of x this time, same. Okay, now we are going to apply the by parts. You're going to apply the by parts formula over here. Okay, so for your convenience, let me rewrite the formula for you because it was written at the back side of the page, so I'm not going to turn it again and again. So for your convenience, this is the formula of the by parts. Okay, and that's what we are going to apply over here. This time this is over this, and we have to apply the by parts at this side. Okay, so fn small g, f dash x, and capital G of x right in front of you. Simply substitute over here, and you are going to get your new form. So let's see what we are having now. So I is equals to, this thing is going to be copied as it is. Okay, and then you open a big bracket because you have to put down this whole thing here. So this 2 by 3 is outside the integral, so just apply a square bracket here, and then you just put down this by parts formula. So you see f and g is this, so it is going to be e power 3 upon 3. This is your capital G, and small f is your this, so you just write it down. There you go. Minus integral f dash x is this, and g of x is this. So it is going to be minus 2 sine of your 2x dot e3x upon 3 d of x. Close the bracket. Okay, now this 2 by 3 is going to be written outside this integral, and this negative and negative becomes positive, you know. So now how about if I simply multiply this negative 2 by 3 with both these terms? So it is going to be minus 2 by 9 okay, you're having three negative signs, minus, minus, and plus minus give you minus. Okay, and this 2 upon 3 and this 2 upon 3 on multiplication give you 4 by 9. Okay, integral e of 3x sine of 2x dx. Okay, now you have noticed, you can notice here that this integral is the one that was mentioned in the question. Okay, you can see it. And if I turn my page, it is similar to this, and it was your I. Okay, so it means that, hang on for a second. So it means that this integral is your I. So at this place I'm going to write my 4 by 9 into I, and then I'm going to shift this I part over here at the left hand side, and my work is set to be done. Okay, so let me write this step over here. And this is your I, so let me write I here. Okay, now I'm going to shift this term of my right hand side towards my left hand side, and I'm going to get my answer finally. So let us do it. So after shifting, it looks like this. All right, and now you're going to take out the common LCM. You simply take out I common here, so over here just 1 is left, and with this term you're having 4 by 9 is left, and you take out the LCM the next step. Okay, so while taking out the LCM, you're having it 9, and 9 plus 4 plus I. And in these two terms, I can take out e power 3x upon 3 common. So inside, just this is left, 2 by 3 cos of 2x. Okay, and this is going to give me 13 by 9 into I. This is going to be copied as it is. What I have to do, I'm going to shift this 13 by 9 on the other side of equality, so it will get inverted. Okay, the simple I is going to be 9 by 13 into e power 3x upon 3 sine of 2x minus 2 by 3 cosine of your 2x. All right, and you know that this I was your this. So finally, the answer of this integral, which was whose integrand was quite non-terminating, comes out to be this. This is the answer. Okay, so there you go. So that's how you solve the non-terminating integration by parts by means of the I method, because I method helps you in ending up the entire evaluation. All right, so if you find this video helpful, just subscribe my channel and hit on the like if you feel that you have understood the concept. And in the next video, we are going to discuss one more example related to this non-terminating integration by parts. So keep in touch, and Allah Hafiz.